and so I think the point, the problem, the opportunity is to move forward from the traditional process mining approach to what Gardner is calling the digital twin of an organization, that is a dynamic model, a more precise model that is provide you all the information needed in order to replicate the concrete behavior of the process using your simulation software. And we will see how we built it. So the idea is that we can get the information from the different stakeholders of the organization, even from physical device, and provide you with the end-to-end process streamline. So in this case, we will see an order to delivery process that is managed on Salesforce, SAP, automation anywhere. So we have also robot involved. But the critical point of, let's say, the transition between process mining and digital twin is the capability to provide additional information that are transforming your dynamic model in a real precise model. So we start from process discovery. In the process discovery phase, we identify the frequency of your process, so the main part of the process, and this is by quote traditional process mining approach. But then we will need to analyze manual activities. So manual activities that have not a digital footprint. So in order to do it, we need a BPA platform in order to add to the dynamic model of your process the manual activities. And we can do it with MindVinio. And the next step, it will be to analyze the performances of your process. So also related to resources, role inside your organization. But performances and frequency is enough? Probably not, since we wanted to improve our process. So we need also to consider costs. And in order to consider cost, we need also to consider business hours, because luckily we are not working 20 hours per day. Robot probably will do it. And the next step is also related to the innovation that we are bringing to the market with the new version of MindVinio, that is the capability to automatically derive the decision rule from the data. So we want to move from probability concept to rules. And this is a big improvement on the quality of the process. As next step, we use all the information, including the reference model. So the way we expect the process should be executed in order to identify how to improve it, identify the deviation, identify the source of inefficiencies. And we constantly monitor also the automation related to chatbot, related to RPI bots, related to AI algorithms, all the stakeholders that you have inside your organization. Last but not least for importance, we need to run a simulation. So we have a really sophisticated simulation engine that will let you define what-if scenarios using bpmN, using decision rules in order to identify the return of investment before moving forward with the implementation. So this is the idea. And for sure, we are providing an important enablement to your robotic process automation. So we can analyze the disease, simulate the to-be, identify the ROI, implement your robot, and constantly monitor it. We are going to introduce today Credem's success story. So they started the digital transformation journey. Credem is an important bank in Italy, one of the most important ones. They started the digital transformation journey with MindVinio as the solution for the holistic approach for business process management, analysis, and improvement. And they selected as the architectural step IBM DBA platform. So as you can see in this slide, we have MindVinio that is managing the governance of all the digital transformation of Credem Bank with RPA, with IBM BPM, and so on and so forth. And what we are going to provide you today as demo is the banking account closure. So the customer wants to simply, using RPA, reduce the cost and be compliant with the normative rules of closing a bank account that are, you must close the bank account in 12 days. And so we're going to show it with the demo. So here you can see MindVinio in action, the frequency view, with a lean approach. So dark blue activities are the most frequent one. Here you can see request created. And ball transitions are also the most frequent ones. So we can immediately spot the most frequent path of the process. But we can do even more. So we can identify the compliance according to our normative reference model. So we loaded the normative reference model, and MindVinio is telling us that there is an activity that should not happen. It's not in the epipet. That is the pending request for acquittance of fares. So, and immediately provide us information about time and cost and performances when we are compliant with the normative reference model or when we are not compliant with the normative reference model. You see, easy, straightforward. And what we can identify, immediately identify, is that 7% of the activities are repeating the BO service closure, the closing of back office services. So this is a real source of inefficiency, you know? And we double the lead time, and also we increase the costs. But we have a dedicated view that is the automation level and rework view. So here we can see that all the activities as of today are manual, but BO service closure is really critical. Again, lean approach is stating MindVinio that BO service closure for 6,000 cases, 7% of the overall cases, has been repeated on average 2.3 times. So the customer starts thinking, okay, but why this activity gets repeated so frequently? Now we need to focus also on performances. So we move forward with our journey in order to identify the source of inefficiency. And again, lean approach, dark red activities are the longest one. Again, BO service closure is critical, stands on average 55 hours, you know? And since we have a precise model of the process, we can compare it using our key performance indicator. And so in red, everything is fine. Sorry, in green, everything is fine. In red, again, BO service closure is critical, also from a key performance indicator perspective. And we have also pending liquidation request that is borderline, you know, it's yellow. So, and as next, we need also to consider costs. So in order to consider costs, we move to our advanced analytic dashboard that is dedicated to, in this case, to monitor the automation trend. And we can see, we will see, hopefully. And we are going to see the list of activities and the cost related to each activity. So the customer will be able to identify if BO's service closure is relevant also from a cost perspective. Please, network, help me. So, don't know what we can do. Let me try to refresh.
No.
So I think, Luca, you can move forward,
yep,
showing the innovation that we bring that is related to the decision mining. So we are able to derive also the decision rule from the data. And then, is answering. Thank you. Thank you, Nectar. Thank you, MindVinio. So here we can see, that we have the list of, the activities. And the ones that are influencing the cost are mainly evaluating request and BO service closure. So BO service closure has an average cost of €4 and on average $300,000. So this customer decided that he wants to start the automation with BO service closure, but before moving forward, he wants to run a simulation. So define what if scenarios and see what will be the result related to the automation. But we will use also the decision rule. So now Luca will introduce us the innovation related to decision rule.
Thank you, Max, for the introduction. So typically, what a process owner has to do in order to manage his business process is to create a reference model that basically is regulating the flow of each process instance. And also, he has to create the decision logic, the decision rules that will regulate the flow of the process instances in the decision point of the model he just created. So he can follow two standards that are released by the OMG. They are the bpmN for the model and the DMN for the decision rules. As you can see here, we have designed, with the help of the business owner, the process owner of the banking account closure process that Max just described, we designed the decision logic of that model. And so, for instance, if we open here this decision table that is called the analyzed closure type, we can see that we find the condition that will bring us to the three different kind of closure type, that are the client recess with or without the ladder and the bank recess. But let's move on. So the power of MindVino is that the user is allowed to automatically derive the bpmN directly from the data without having to design it. And now with this new feature that we have created, the user is also allowed to discover the decision logic behind the decision point of this model. So if we just click the rule discovery button, what happens behind the scene is that with the help of machine learning, we are trying to find the correlation between data and the decision point here that are basically the splitting points. So as you can see here, for instance, we have found a correlation between the closure type, that is a contextual data, and the gateway 17. So if closure type is inheritance, we follow this path. Otherwise, we follow the other path. And now we can check if everything is correct. And suddenly we see that here, this output branch has been enhanced with the rule not found. That is because we didn't find any correlation with the default settings that we have at project level. But there's no problem in that, because the user, with an iterative approach, can also toggle those configuration. And for instance, if we just decrease the minimum score here, we're allowing the machine learning model to go a little bit deeper in finding the correlation. So if we hit the rule discovery only for this gateway, you will now see that now we have found a correlation with the working state. So again, if the working state is in client retrieve, we follow this path below. Otherwise, we go to the other branch. So this new feature will allow the user also to use those decision rule to be considered in a simulation scenario. So if you create a new simulation, just clicking here, we are computing all the statistics of this event log, and also we're taking into account the decision rule that we just discovered. And in the gateway section of the simulation scenario, we will see that those conditions will be taken into account as soon as it loads. Yeah, that's called machine loading, not machine learning. Okay. So as you can see here, we have all the conditions. But since we are running a what-if analysis, the user may also want to change those conditions that we have discovered. And he is allowed to do that. So as you can see, we can change this condition here, just allowing to take into account the inheritance kind or also the porting. And also we can exclude this type here in the other path. And if we click Save, the simulation scenario will be updated. But we talked about automatic business rule discovery with that follow the DMN standard. Right now, we have only found some expression. The user now is allowed also to promote the decision rule that he has evaluated and validated with the iterative approach that we described a few seconds ago. So if we call this, we input in this form the name of the decision table, evaluate closure type, and we call it closure type, the output value. The user is prompted with the decision table editor that has already been pre-filled with field expression language. So the conditions that were found in a Boolean logic now are transformed in a field. So after we click Save, you can see that the output branches have been changed and updated with the new output variables of the decision table. But what happens?
So now we are connected to the decision table.
Yeah, now in the gateway we have the connection. As you can see, we have the orange gateway. But what happens if the user want to link an existing table that you already have created for this process or another process? Well, it's just as easy as selecting the decision table that he already has in his repository and just assign, map the output values to the output branches. So we know that if we are in a bank recess, we have to go to the authorization request, or if it's a complete client recess, we go to BO service closure. As you can see, we have left empty some output values. There's no problem in that because the user is allowed to do that. But if we click Save, you see that now the gateway has a linked decision table, but now turned blue, letting the user know that there is a linked decision table, but there is not a perfect overlap between all the output values of the decision table and all the output branch of the gateway. Since we're running in a simulation scenario, the user could also want to change the BPMN that is linked to this simulation scenario. So maybe he want to just add an activity. And
sorry, Luca, this is the case where we add a manual activity.
Yeah.
That has not a digital footprint related to the data.
So we can call this new activity notify customer. And then if we go back to the scenario, we'll see that everything has been updated accordingly. So we have now the closure type here that has a new porting, and the closure type has been taken into account. That is the output of the decision table. And also, we have the new activity here, notify customer, that has been updated. So now that we talked about the business rule discovery using the contextual data, we'll let Max explain in more details the third key point that we want to focus on, that is the simulation scenario.
Thank you, Luca. So we have the digital twin that is configured with all the information needed. As you can see on the top of the page, we can see the actual lead time and the estimated lead time. So the idea is to have a sort of spreadsheet where we can change things and see if we reach the objective, in terms of time and cost. Since our objective was to use RPA in order to reduce the time and the cost, we now go to the bioservice closure activity that is there, you see. We wanted to reduce the human resources from 5 to 3, and we wanted to automate 90% of the activities. And the working time of the robot will be 12 hours per day. So, and the processing time 1 minute. As you can see, MindVinio is automatically identify what will be the lead time of the process working with the robot, and also the cost of the process working with the robot. So the customer is happy. I reach the objective, I can move forward with the implementation of the robot. In order to generate the real, because we are going to generate concrete cases related to this to-be model, we have also to select the arrival distribution. We select historical, so we are considering the behavior related to the past processes that has been managed, and we have also to identify when to start to generate activity. So we know that the last day of real activity was the 6th of March, and we tell it to the simulation engine. We have done. So now we have just to run the simulation engine. The simulation engine is generating 20,000 cases in the future, and we will be able to import it in MindVinio in order to see the potential changes related to the estimation that we provided on the simulation panel. Because the estimation is considering the effect of the robot, but is not considering the potential queue that we can generate related to the end-to-end process. So we will need to check it. And what we can see is that, okay, we are not creating queue. You see 4 seconds on average related to bioservice closure when it's performed by a robot. So we can just tell to MindVinio that we want to import the simulated scenarios. Hopefully. Please, MindVinio. I don't know what happened. I think this is a network problem. Sure. We let it work. And so we will import the data into MindVinio, and we will be able to verify if the assumption made is correct. So in this idea, we have a dynamic model. We simulate the future behavior of the process. We concretely define the to-me model related to business rule, related to behavior, to activities that we can add to the process. And we simply ask then to get the data from the simulation and import it. So now we are going to visualize again the process model. So MindVinio algorithms are working also on simulated data. And please, okay. And here we are. We have the additional activities, that is the manual activity that we added. So now it's part of the end-to-end process. We can see what are the performance of the activity. But we can check the performances related to the simulation, the simulated tasks managed by the robot. Here we are. We are in time, so we can wait 1 minute. At the meantime, do you have any question? We have time for question and answer. Nobody?
Is the decision mining unique? Have you seen others do that?
Not yet.
Decision logic?
Not yet. Maybe next year we will see somebody. Not as of today. No, not as of today, as we know. So here we are. This is the typical, dashboard that is analyzing the automation trend. So we can immediately check when the activities are managed by the robot, what is the lead time and the cost. And here we can see the overall performances and cost, and the cost related to the filter that we selected. So when the robot is working, the average lead time is 13 days, and the average cost is $14.55. So we reach the objective, we can remove the filter, and also compare the management of bioservice closure when the robot is working, so 0.3 euro on average compared to 4, and when the people are working on it. And we can also constantly monitor the automation trend. So this is really important, I think, because when you when you need to manage the scalability of your robotic process automation journey, then you need to be able to constantly monitor the resources allocated, the manual activities, the real percentage of automation related to your robotic process automation journey, and also the compliance of a robot. So with this approach, we can control resources, allocation, manual activities, automated activities, and we can also go on the process flow and check the compliance related to the robot. That's all. If you have any question.
Similar to the question to what we asked the gentleman before you, which is, how did you capture this detailed event stream? Are you recording it? I mean, how do you get this layer of keystroke UI actions at a level that's deeper than just the transactional state? We are getting the information about the log that are traced by the robot, and here we are simulating that. So we are not recording. This is the advantage of MindVinio. Since we have the simulation engine, we can state what will be, the behavior related to the robot. Specific paths that
Yes.
a robot will do and
Yes.
simulate.
You define what will be the path followed by the robot, what will be the percentage of automation that will be managed by robot, because you can have error, you can have some specific path that could not be managed by the robot. You can use, this is really important, contextual data and business rule in order to define, if you will, through path A or path B. Most of the competitors are only considering probability, and there is a big difference in terms of precision.
But the baseline trace, where you get that?
The standard event log.
From the event log.
Event.
Yes. We can get it also from the front-end behavior, and it's something that we are working on, and it will be delivered before the end of the year, probably in partnership with some RPA vendors. Because, it doesn't make any sense to re-implement the wheel,
So two questions of clarification. You used two terms that triggered my brain. One was machine learning to discover the rules.
Machine learning models.
So that doesn't quite cue in my brain. So
I let Luca.
So the word machine learning may be a little bit, so what do you mean by machine learning?
We're using some machine learning models to automatically discover the rules. That's what we call machine learning. So we are using models of machine learning to find the correlation within the data. So we're basically creating a model for each of the split gateways, machine learning models that will taking into account all the contextual data and finding which are the conditions that give me the path A or path B. But so we're finding correlation with machine learning models.
Okay. And simulation, do you mean discrete event simulation or just distribution?
For the simulation, I mean, we are considering the historical distribution to create a new distribution, a synthetic distribution.
When you're talking simulation, you mean?
Yeah, as you saw, he selected the historical distribution.
Historical. Yes, in this case, we selected the historical. Yeah, correct. Michael.
Cost. How did you capture cost?
Oh, cost it's an input information. So you can provide the cost related to activities, resources, and role. So activities are fixed cost related to resources and role. It is tightly coupled to the working time. So these are input information that then we use in all the different variants in order to identify the difference in terms of cost when you follow the different paths.
Second question, who is building this? What's the skill set that you need to have to build these types of reports, experiences? Is it a data scientist? Who is like as you're building these reports?
You mean to build what?
To build the dashboards and the experience. What's the skill set?
Oh, I mean, to build the dashboard is what you see is what you get. So you need to be able to work with an expression language, because then for some queries you need to write using an expression language approach. That's all. So knowledge of SQL, you know, and what you do with the typical business intelligence product, so is the same level of knowledge. Any other question? Yes, please. I can show you I mean, it's really fine grain. I mean, you go to the level of activities. So we have activity cost, and we can provide the cost also for the robot, because, you know, it will be different when the robot are working. You have the default cost for sure. You have activity working time. So for each activity, we need to provide as input the real working time, because, you know, we can only get the service time related to the activity, but not the real working time of each activity. Between different persons, you mean? You could even do it. You could even do it, yes. Because here in resources, you could even say that max, you know, it's a little bit old and it takes more time to perform the activities. Yes.
That's assumption.
Oh, you know, from a working time perspective, is an assumption. Yes. From a service time, no. So I can see that max, on average, for when he's performing the activity, his service time is 2 days, and when the Luca is performing the activity, his service time is 1 day. I don't know the working time, but for sure max is a little bit longer in doing it. Okay? Any other question? So, thank you so much. Thank you.